Ship 39 has been sitting in Mega Bay 2 for weeks, fully stacked but not moving. Then on January 2nd, the doors opened and revealed something shocking. Scaffolding everywhere, and crews working on a massive upgrade. What could be so important that SpaceX would delay rollout? They've just finished upgrading all 18,000 heat shield tiles with new materials and crunch wrap technology. This isn't just any test flight anymore. Could this heat shield finally be strong enough for Ship 39 to survive orbital reentry and catch on Mechazilla? Let's find out on today's episode of New Space Review. So why has Ship 39 been stuck inside Mega Bay 2 for so long? Turns out, there are two main reasons. First, SpaceX is building a new support structure at the Massey site. They're calling it the truss structure. This thing is designed to make cryo-testing and static fires faster and safer. Ship 39 won't roll out until it's done, probably within a week. But honestly, that's just the practical side of things. The real story goes back to late December, when Booster 18 exploded at Massey. That explosion didn't just damage hardware, it threw SpaceX's entire timeline into chaos. NASA's Artemis program is breathing down their necks. The moon mission schedule keeps getting tighter. They couldn't afford more delays. So SpaceX made a call. Instead of rushing Ship 39 out for testing, use this extra time to make it absolutely perfect. Why test a good vehicle when you can test a great one? And that scaffolding we saw on January 2nd, that tells us everything. SpaceX has spent the last few weeks methodically upgrading the heat shield on this spacecraft. We're talking about touching every single one of those 18,000 ceramic tiles that protect Ship 39 from 1,500 degrees Celsius plasma during re-entry. Some tiles got reinforced, others got repositioned. Critical areas received completely new tile configurations based on lessons from previous flights. Now, you might be wondering, why not just use Dragon's heat shield? Dragon uses Pica-X, an ablative material that's worked great over dozens of ISS missions. It handles temperatures between 1,600 and 2,000 degrees Celsius without issue. But here's the catch. After every Dragon flight, parts of that heat shield need inspection and often replacement. That's fine for a capsule that flies maybe a dozen times a year. But Starship? SpaceX needs a vehicle that can land on Mechazilla, get restacked, refueled, and launch again within hours. Pica-X can't do that. So what's the plan here? Originally, SpaceX was going to continue the extreme testing approach from the V2 flights. They were going to deliberately remove tiles from key areas, strip away the ablative layer, and push Ship 39 to its absolute limits. The logic was simple. If it survives that kind of punishment, the basic design is way more resilient than anyone thought. Those 5 V2 flights in 2024 taught them exactly which areas could handle flight without tiles and which spots needed serious reinforcement. But something changed. Instead of removing tiles, they're adding them. They've spent extra time installing additional heat shield protection in those critical hotspots that previous flights identified as vulnerable. This shift tells us something important. SpaceX thinks Ship 39 is ready for something bigger than just another data collection flight. If re-entry goes well with this fully protected configuration, Ship 39 could actually try landing on Mechazilla. That would be historic. Let's talk about the star of this upgrade, crunch wrap technology. You might remember the name. Yeah, it's borrowed from Taco Bell's Crunchwrap Supreme. But there's nothing funny about what it does. This flexible, ablative sealant fills the gaps between tiles without traditional gap fillers. It was first tested on Flight 10, mainly on the nose cone. It works like a fabric layer that seals tiles, trims edges flush, and most importantly, stops superheated plasma from sneaking through the gaps. Elon Musk praised it after Flight 10, saying the new heat shield performed way better than expected. But here's what makes Ship 39 special. SpaceX didn't stop at the nose cone this time. They've applied crunch wrap across the entire body and all 4 flaps. This is a massive expansion of the technology, and it shows how confident they've become in it. Flight 10's results showed crunch wrap worked exceptionally well in most areas. It prevented serious tile wear and oxidation. Sure, there were some spots with orange residue on the edges that needed work, but overall performance was solid. By Flight 11, its use had already expanded. Now, with V3, it's everywhere. This crunch wrap layer reduces plasma heating and critically prevents that plasma from seeping into the stainless steel structure underneath. If Flight 12 succeeds with this system, it opens the door for the entire Starship V3 fleet. Ship-to-ship orbital refueling tests, maybe even a trial lunar mission by mid-2025. But not everything worked perfectly. Let me tell you about a bold experiment that didn't pan out. During Flight 10, SpaceX quietly tested something interesting. They replaced a few hexagonal ceramic tiles with metallic versions made from heat-resistant stainless steel. On paper, it made sense. Metal tiles could be more durable and easier to replace than ceramics. Reality disagreed. According to Musk, those metal tiles reacted badly with superheated oxygen during reentry. The result? Severe oxidation and a massive orange discoloration right in the middle of the vehicle. Starship still completed its mission and landed precisely in the Indian Ocean, but that visible damage was a clear warning. The oxidation meant time-consuming refurbishment between flights, which goes against everything SpaceX wants. By Flight 11, they ditched metallic tiles completely and went all in on refining the ceramic heat shield with much tighter sealing. And Flight 11? That was the ultimate stress test. SpaceX engineers deliberately removed around 72 ceramic tiles across 18 of the hottest regions on the vehicle. They didn't even leave the ablative backup layer underneath. Bare stainless steel was exposed directly to reentry plasma. The goal was to collect critical data for developing lighter, more efficient heat shields, maybe ones that don't even need full tile coverage. Everyone expected the worst, but Starship shocked us. The vehicle held together impressively, showing only minor discoloration, far less severe than Flight 10's damage. Post-flight analysis revealed something remarkable. Starship is extraordinarily tough, even when pushed beyond reasonable limits. Both Flight 10 and Flight 11 survived atmospheric reentry without losing control. That's why Flight 12 matters so much. With the heat shield in its best condition yet, we're about to see just how far this technology has come. While all this was happening, Starbase itself has been transforming. On January 6th, the QD arm extension for Pad 2 was finally rolled out to the launch site. This massive piece of hardware handles fueling and stabilization once Starship is stacked and ready to launch. The installation speed was impressive. By January 8th, it was nearly complete. That same day, SpaceX lowered the chopsticks beneath the QD arm to run movement tests, swinging them left and right to check the stability of newly upgraded actuators. Pad 2 is racing toward flight readiness. SpaceX has also been installing additional clamp arms on the orbital launch mount at Pad 2. These clamps hold the full weight of Super Heavy and Starship during fueling, checkouts, and engine startup before releasing the vehicle at liftoff. By January 8th, 12 clamp assemblies were already in place. All this rapid progress suggests Flight 12 could happen sooner than many people expect. One more piece of good news worth mentioning. Recently, the U.S. Congress pushed back against President Trump's proposal to slash NASA's budget for fiscal year 2026. Trump wanted to cut about $6 billion, bringing NASA's funding down to roughly $18 to $19 billion. But Congress reached a bipartisan agreement, allocating about $24.4 billion to NASA, only a modest 2% cut compared to 2025. This protects NASA's core missions and rejects plans to eliminate STEM education programs. For SpaceX, this matters. They're the primary contractor for NASA's Human Landing System, with Starship selected to land astronauts on the Moon during Artemis 3, currently targeted for 2027 to 2028. A stable NASA budget means those multi-billion-dollar contracts stay in place, giving SpaceX the financial certainty they need to keep pushing Starship forward, while also strengthening America's competitive position against China's rapidly advancing space program. So, here's the bottom line. Ship 39's upgraded heat shield isn't just another incremental improvement. It's SpaceX's best shot yet at catching a Starship that's actually been to orbit. All those weeks of work, the 18,000 upgraded tiles, the expanded crunch wrap coverage, it all points to one goal: proving full reusability is real. If Flight 12 succeeds, we're watching history. Hit that like button, subscribe to New Space Review, and drop a comment. Will Ship 39 stick the landing? Thanks for being here. Now click that screen to see how Raptor 3's insane upgrade is reshaping Mars plans. It's mind-blowing. Raptor 3 upgrade shocked NASA. 280 tons changed Mars.